In this particular lesson, we're going to be looking at how to solve exponential equations using a few different methods. And to start with, here are three different equations, but only one of them is an exponential. But sometimes I'll see people get these three mixed up, and so I really want to be clear up front here about how we would solve each of these three types. So the first one that we have here, the 64 equals 2 times x. Yes, that 2x means multiplying it. So if I wanted to solve this, I would have to divide both sides by 2, which means then we get 32 equals x. Okay, now the next one, 64 equals x squared. We still see an x and a 2, but notice this time the 2 is in the exponent. So in order to solve this then, I am actually going to need to take the square root of both sides. And so the square root of 64 is 8. So you might be thinking 8 equals x, but remember, anytime you take a square root or any even root of both sides of an equation, you need to include both the positive and negative versions of that answer. And so here x equals 8 or negative 8. Right? And then we hit our new one. 64 equals 2 to the power of x. X is in the exponent this time. Now, one way you could do it in this particular case is you actually could do a little bit of guess and check. You might actually be able to figure out 2 to the power of what is 64 because it's a nice pretty whole number. However, there is actually a way we can calculate it where it works even if it's not a nice pretty whole number. And that is, of course, what we've been practicing doing with exponentials all year long, which is changing them into a logarithm. So if you start by taking this particular equation and rewriting it as a logarithm, we will get log base 2 of 64 equals x. Well, notice log base 2 of 64 is something we can calculate. In fact, we saw that in order to calculate that, we would use the change of base formula, which would be log of 64 divided by log of 2. And then we could punch that in the calculator to find the answer. And in this particular case then, that's going to give us 6. And so then in this particular case, x equals 6. And through this problem, we see that we now have a method for solving an exponential equation algebraically. You write it as a logarithm. And we will be practicing that. But first, let's delve into this problem. Because in order to be able to solve this problem for x, you actually could have done it before we even introduced the idea of logarithms. Because if you can graph something, you can actually solve it. So if I went through and actually graphed y equals this negative 8 times 2 to the power of x minus 4 plus 3, I would start by putting in my asymptote up here at positive 3. And then it's going down because it's negative. And so I go ahead and I plot all those points for that. In case you're curious how we would plot this, the place to focus your attention is that is the first point that I would have plotted. Notice that that point there is right 4 and down 8. All right, now if I have that graph, I can then look to see where does that graph hit a value of 1. In other words, when does the y-coordinate hit 1? And so you can see that point of intersection is right there. And so we want to solve it for x, right? So then what does the x-coordinate equal at that point? 2. And so we could look at the graph and figure that out. But of course, again, that only really works well if it's at a nice, pretty number. If it's at a decimal, it would be at a bit of a loss. And so let's take a look at how we could solve the exact same problem algebraically this time. All right, now in our very first problems that we did, we saw that we can change it into a logarithm in order to solve it. And that is definitely true. However, in order to be able to turn this into a logarithm, we have to do a little bit of work first, because you need the exponential part of your equation by itself first. That's, in this case, the 2 to the power of x minus 4. And so we need to then get rid of that minus 8 and that plus 3 before I can turn it into a logarithm. Of those two, the very first thing I would get rid of then is the 3 because it is being added. So I'm going to subtract 3 from both sides. And so I now have negative 2 equals negative 8 times 2 to the x minus 4. I now need to get rid of that negative 8. Since that negative 8 is being multiplied, I'm going to divide. And so when I divide both sides by negative 8, I end up with 0.25, notice it's positive, equals 2 to the power of x minus 4. And yes, it is positive because we did a negative divided by a negative. Right, now I have that exponential by itself over here on the right side. Therefore, our next step is to go ahead and turn it into a logarithm. So we're going to rewrite it as log base 2 of 0.25, and log always equals the exponent, right? Well, our entire exponent here is not just x, it is actually x minus 4. So include the whole x minus 4 on that side where the exponent goes. Now, we can go ahead and calculate. As you may recall, in order to be able to calculate log base 2 of 0.25, we're going to end up doing log of 0.25 divided by log of 2, and then that gives us negative 2. And so if negative 2 equals x minus 4, in order to finish solving it out, we just have to add 4 to both sides. And so x here just equals a positive 2, because negative 2 plus 4 is 2. And that would be our final answer. So notice, we did end up getting the exact same thing, whether we did it graphically or whether we did it algebraically. The difference is that, well, one, we didn't have to make a graph, and two, if it had worked out to ending up being a decimal, we still would have been okay here. We're going to practice that technique with one last problem. And in this case, we don't know whether our answer that we should expect should be a decimal or an integer or what. And so we just have to work it out to find that out. Now again, we want to start by trying to get the exponential part by itself first. That is whatever is raised to the power and the power itself. So in this case, then I have to get rid of the 5 and the 7. I always want to get rid of addition and subtraction first. So I'm going to start by subtracting 7 from both sides. All right, so then I now have 40 equals 5 times 2 to the power of x minus 3. Now I can get rid of the 5. Since the 5 is being multiplied by it, I'm going to divide both sides by that 5. And so 40 divided by 5 is 8. So 8 equals 2 to the power of x minus 3. All right, we've successfully isolated our exponential part of our equation. That means I can now turn it into a logarithm. And so we now go to log base 2 of 8 equals x minus 3. And again, we could use the change of base formula to calculate log base 2 of 8, but I hope that you actually see how you don't even need to, because this is actually a very common value, one you might already have memorized. Because log base 2 of 8 means 2 to the power of what equals 8. And I know 2 to the power of 3 equals 8. And so, yes, I could do it the long way on my calculator, or if I happen to know it already, I can use that information. So then, the very last thing we need to do then is we need to get rid of that 3 now. So I can go ahead and add 3 to both sides, and we end up with 6 equals x as our final answer. And so this one did happen to also come out to be a nice, pretty whole number. Certainly, that is not always the case, but the method will be exactly the same whether it's a decimal or whether it's a nice, pretty integer like this.